Okay, so we're going to do a quick problem on finding the inverse of a matrix with LU decomposition. And remember that an inverse is special in that if I have a matrix A and I multiply it by its inverse, I will get the identity matrix. And LU decomposition is how a lot of computers will actually do this in order to find what the inverse of A is. So for the sake of making things easier to understand with letters, I'm going to call the inverse of A H. I'll try to appear that H is equal to the inverse of A. By definition, that's what I'm calling it. In Dr. Call's book, he calls it B, but we use AX equal to B in this class, so I don't want to confuse terminology. So I just arbitrarily created the letter H. You'll probably never see that in any textbook anywhere. That is just mine. So let's do an example. I give you a matrix A, and this is 2, 6, 9, 1, -2, 3, -4, 8, 6. And we want to ask ourselves, what is the inverse? Or what is H? So our first step is to, I don't say break, let's use the actual word, decompose A into L and U, which is a Gaussian elimination thing. So let's eliminate, so first we'll say part A, eliminate, what do we want to eliminate? Well, what we would like to eliminate are these three elements. So we'll go ahead and eliminate the 1 first. And note that we wouldn't pivot here because I'm asking specifically, what is the inverse of A? I'm not trying to solve a system where pivoting would be better. I want the specific inverse of this matrix. If I change things around, I do not end up with the same exact matrix. So we're going to not pivot anything. We're just going to eliminate the 1 first. So what do we have to do? We have to find our multiplier. Our multiplier is used to modify the first equation, which means we want to modify the 2 by multiplying it by something. And we're going to multiply that by a half. And that will equal that. So we're just going to put on the side that L21 is equal to 0.5. And the reason we know it's 2, 1 is that we're eliminating the variable that is in row 2, column 1. That will ultimately be in our L matrix. So what we're going to do now is take that multiplier, our 1/2, and we're going to multiply that by, this will be our E1 mod. We're going to multiply that by 2, 6, 9, and that will give us 1, which is what we want, 3, 4.5. So what we'll do now is we will do E2 minus E1 mod. That will be 1, -2, 3, minus 1, 3, 4.5. And we subtract element by element. So 1 minus 1 is 0. -2 minus 3 is -5. And 3 minus 4.5 is -1.5. And this is going to be our new equation 2. So A at the moment, if we compare, it's going to be 2, 6, 9, our new equation 2, which we just eliminated that element in row 2, column 1. And then our third row hasn't changed yet. So that's our A at the moment. So now what we want to do is we want to eliminate -4. So that means we're going to multiply our first equation by -4 over 2. Because if we do that, we end up with -4, which is what we want. We want this to match that. Remember, that's our Gaussian elimination technique. We want those to match. And this will end up being our L, and what are our subscripts there? 3, 1 will be -2, right? Because this is -2. Okay, so what we're going to do now is we're going to take our row 1 and modify it. We'll multiply it by -2. And our row 1 is 2, 6, 9. And that becomes -4, -12, -18. And we'll now subtract that modified row from our E3. -4, -12, -18. This would be -4 minus -4, which becomes plus, which makes sense because we want that to be 0. 8 minus -12 is 20. 6 minus -18 is 24. So now our A at this point, if we scroll back up, is 269. That first row hasn't changed. 0, -5, -1.5, now we're going to substitute our new row. 0, 20, 24. All right, last step. I'm going to eliminate the 20. And remember, originally that was an 8, but due to the multiplication and the math we've done, we have to now focus on eliminating 20, and we'll modify the top or the second row, the one right above it, the diagonal. We'll modify this guy in order to do that. So I want to multiply -5 by something. So we'll take 20 over -5. Yeah, because the -5's cancel. That will give us 20. That means that our multiplier L32, row 3, column 2, will be -4. Which you can figure out without doing this whole fraction thing, but sometimes the numbers aren't pretty. So it's nice to just get into the habit of saying, okay, I want to eliminate the -5 and be left with the element that we're trying to match and eliminate. And we'll put that in the numerator. So what we'll do now is we will take our second row and modify it, E2 mod. That is equal to -4, 0, -5, -1.5. This would be 0, 20, 4 times 1.5 is 6. The negative signs go away. So that means that our A after our elimination is 269, 0, -5, -1.5, 0. All right, I didn't do it yet. Whoops. Jumping ahead of myself. I forgot to subtract. So we'll use this in a second. I forgot to subtract. What we're going to do is subtract this from E2 mod. So E3 is 0, 20, 24 minus 0, 26. 0 minus 0, 0. 20 minus 20 is 0. 24 minus 6 is 18. So we end up with 0, 0, 18 as our bottom row. And really, what this is, I guess it's not really fair to say that this is A. I mean, kind of. But we've modified it. It is a new matrix now. So really what this is U. This is our U. And our L is going to be the same size matrix. So we have 1s along the diagonal, 0s in the upper triangle, and then we'll take our multipliers, which are 1/2, -2, and -4. So this is 1/2, -2, and -4. And what I'm going to check in MATLAB right now, and I know you can't see my computer, but all I'm going to do is I'm going to define U, just to double check that this makes sense. And I'll write down in MATLAB, maybe I'll just write it here so you can see what I'm coding. U, 2, 6, 9. When you want to create a matrix in MATLAB with multiple rows, you separate the rows with a semicolon. 0, -5, -1.5, semicolon, 0, 0, 18. do the same thing for L, 1, 0, 0, 0.5, 1, 0, -2, -4, 1. And I want to see if we get back, if we multiply L and U together, do we get the same thing? So 2, 6, 9, 0, -5, -1.5, 0, 0, 18. And I'll say that L is equal to 1, 0, 0, 0.5, 1, 0, -2, -4, 1. And I'll do L times U. And the question is, do we get back our thing? Looking at my MATLAB, this multiplication ends up being 2, 6, 9, 1, -2, 3, -4, 8, 6. So let's double check that this actually works. Let's copy this. So I'll copy that. Let's come up to the original matrix. We'll paste it here. 2, 6, 9, 1, -2, 3, -4, 8, 6. Perfect. So our L and U is correct. Cool. Number 2. We know that A times H is equal to I. So now we'll substitute in LU for A. So it's going to be, instead of A, now we'll have LU H is equal to I. And what we'll do is say that this thing here is equal to Z. So we'll have LZ is equal to I. Now I have to be careful. What's the size of Z? Well, U is 3 by 3. This is 3 by 3. H is 3 by 3 because of the fact it's the inverse of A and it'll be the same size. Therefore, Z has to be 3 by 3. So this Z is 3 by 3. So let's write out what L is again. L was our matrix of zeros and ones, and our L was 0.5, -2, and -4. And we do not know what Z is, but we'll plug in some random placeholders here. And our goal is to find these placeholders. And that has to equal I, which we know is ones along the diagonal and zeros everywhere else. Now, as I mentioned in class, if you look, let's say, at this column here, this top element is 1, 1, this one is 2, 1, this one is 3, 1. And the way that we kind of learned about our matrix multiplication is that we multiply or do our operation involving the row of the first matrix and the column of the second. So this whole column of 1, 0, 0 involves all 3 rows of L, because it's 1, 1, 2, 1, 3, 1. The 1, 2, 3 there are the rows. And all the columns that we use, or the only column that we use is column 1, because of the fact that this is a 1, this is a 1, and that's a 1. So what that means, what we can do to rewrite it, is we can write our L out. Oops. We can write our L out. -4, 1. And we'll just multiply it by the first column of this. And that will give us our first column of I. And now what we'll do is forward substitution. So the first row, or the first equation, says that 1 times Z11 plus 0 times Z21 plus 0 times Z31 is equal to 1. Therefore, that Z11 is equal to 1. So we'll highlight that so we don't forget. Okay, next one says that half of Z11 plus Z21 is equal to 0. Half of Z11 is half of 1. That is a half, which says that Z21 is -1/2. And the last one is negative 2, z11 minus 4, z21 plus z31 is equal to 0. Let's go ahead and plug in our numbers here. So this is going to be negative 2 times 1 minus 4 times negative 0.5 plus z31 is equal to 0. This is minus 2. And you have negative 4 times negative a half. That's going to be plus 2 plus z31 to 0. That says that z31 is 0. So we have 1, negative a half, and 0. Maybe we'll go ahead and actually plug these in here. Z11 and all these guys. Let me see that Z11. I'll do it in red or something. 1, negative a half, and then 0. So, good progress. Okay. Next, what we have to do is the second column, which will say that the same L times, we're still doing the same thing, but now we're going to do it at the second column. So our L again is 1, 0, 0, 0.510, negative 2, negative 4, 1. Did I do that right? Negative 2, negative 4, 1, yep. So now we'll multiply this by the second column of Z, which is Z12, Z22, Z32. If you come back up, you can see that that is the second column, this guy. And that will give us this second column when we do the multiplication, 0, 1, 0. This equals 0, 1, 0. So what do we learn? 1 times Z12 plus a bunch of zeros is equal to 0. That says that Z12 is equal to 0. Oops, I gotta pause this for a second. Okay, we're back. So the last thing we ended with was finding Z12 and seeing that that is 0. So what we'll do now is go to the second equation to find Z22, which has that 0.5 Z12 plus Z22 is equal to 1. Well, Z12 is 0 based on what we just found, so that's 0. So that tells us that Z22 is equal to 1. Easy. Last equation says that negative 2 Z12 minus 4 Z22 plus Z32 is equal to 0. We know that Z12 is 0, so that goes away. We have negative 4 times 1 plus Z32 is 0, which says that Z32 is equal to 4. So 0, 1, 4 is that column, so let's come back up to here. And we'll erase this. This is going to be 0, 1, 4. Now, our last set of z's come from looking at the third column, 0, 0, 1. So we'll go to the third column now, where again our z's is a negative 0.5 or 0.5. 1, 0, negative 2, negative 4, 1. This is our third column, so Z 1, 3, 2, 3, and 3, 3. That has to be equal to 0, 0, 1. So looking at the top equation, Z13 is 0. It has to be because it's 1 times Z13 plus a bunch of zeros equal to 0. Then you have 0.5 Z13 plus Z23 is equal to 0. Well, that's easy because we just found that Z13 was 0. Therefore, Z23 is equal to 0 as well. That's easy. Last one, negative 2 Z13 minus 4 Z23 plus Z3 is equal to 1. that's 0, that's 0. So we get that Z33 is equal to 1. 0, 0, 1. So this last column is 0, 0, 1. So what I'm going to do just to check that real quick is I'm going to make a new matrix that I'll call Z in MATLAB. That's 1, 0, 0. I get 0.51, 0, 0, 4, 1. And if I do L times Z, that should hopefully give me the identity matrix, which it does, looking at it in MATLAB. So our Z is correct, which is great. So I'm going to copy this Z because we're going to use this Z now. Let's copy this. So now that we know what Z is, we can come back here and say that that Z is equal to U times H. So let's come down here now. And what we just said is that U times H is equal to Z. Everything is 3 by 3. So our U matrix was 2, 6, 9, 0, negative 5, negative 1.5, 0, 0, 18, times our H matrix, which is what we want to find. That's our goal for this problem. That has to equal our Z matrix, which I'm just going to copy and paste. Maybe we can move some things around. Can move as close as possible. I know we can do this. Okay, cool. So this is our U times H is equal to Z. Let's double check our U. 2, 6, 9, 0, negative 5, negative 1.5, and then 18 in the bottom right. Cool. So what do? The same type of deal. Our first column is made up or created using the first column of H. So if I were to do the first column, we're going to repeat these same steps now. We'll take U, and we'll multiply that by the first column of H. And that better give me 1, negative 0.50, which is my first column of Z. So now we'll do back substitution to find our inverse terms. What we see is that 18H13 is equal to 0. Well, that means that H13 is equal to 0. Okay. Our second term says that negative 5H21 minus 1.5 H31, that is equal to negative 0.5. H21 is 0, so that goes away. So you have negative 5H21 is equal to negative 0.5. H21 is equal to 0.1. If I did that correctly. Double check, just to be safe. 0.5 divided by 5. Yeah, 0.1. Negative signs cancel. And the last one says that 2H11 plus 6H21 plus 9H31 is equal to 1. Well, we know that H31 is 0. And we know that H21 is a tenth. So we'll just subtract some things over. 1 minus 0.6 is 0.4. So we get that H11 is equal to 0.2. So we'll come back up here now and we'll replace that column with what we just found. So we have H13 is 0. H21, sorry, it should be H31, not H13. We'll fix that, sorry. That should be H31. H21 is 0.1. Make a better 0 there. And then the H11 is 0.2. So what I am going to do is I'm going to double check real quick that we're on the right track. So I know that A is equal to L times U. I'm doing that in MATLAB real quick. And I'll look at the inverse of A to make sure that this is looking right. 0.2, 0.10. Okay, we're in good shape. Because I'm winging this right now. I don't have any work in front of me. I've never solved this problem before. So we have to make sure that we're doing it correctly with each step. All right, second column. We have the same U. -5, -1.5. Now we'll multiply by the second column of H, which is H12, H22, H32. That has to equal the second column of our Z matrix, which if we come back up, that's 0, 1, 4. 0, 1, 4. So, back substitution again says that we're going to take 18, multiplied it by H32, and that'll give us 4. So that means that H32 is 4 over 18, which is 2 over 9. And if we do 2 over 9 in our calculator, we get 0.222 repeating. We'll leave it at 3 sig figs. Okay. Next one says that -5 times H22 minus 1.5 times H32 has to be 1. So that's -5 H22 if we bring the 1.5 over to the other side. We'll end up getting, let's do that math now, 1.5 times 0.22 plus 1 divided by 5 negative is a negative 0.266 repeating. So what we'll do is say it's 267. If we're going to do 3 sig figs, we'll make it 267. Cool. Last one. 2 H12 plus 6 H22 plus 9 H32 is 0. So we have 2 H12, which we're trying to find. That will be 0 minus 9 H32 minus 6 H22. Doing on my calculator real quick, and then we divide by both sides by 2. We would ultimately get 0 or a negative 0.2. With 3 sig figs, it ends up being 0.198, but just for the sake of matching MATLAB, which does it exactly, or close to exact, I'm just going to match them so that we can jive with the results. So negative 0.2. Let's go ahead and plug these in now. So we have negative 0.2, negative 0.267, and the 0.222. Last column. And the last part of the problem. So we'll take the same U. -5, -1.5. This time we'll multiply by column, not Z, H. Column 3. And that should give us the third column of Z, which is 0, 0, 1, which will hopefully make our lives a little bit easier. 0, 0, 1. So, 18 H33 is equal to 1, which means that H33 is 1 over 18. If we do that in our calculator, we get 0.055 repeating. Ultimately, we'll round it up a bit. but it's 5, 5 repeating. 3, oh, that's 2 sig figs. We'll add like that. Now it's 3 sig figs. That's our H33. Second equation is negative 5H23 minus 1.5. H33 is 0. Negative 5H23 is 1.5 times the 0.0556 we just had. Divided by 5 negative. We end up getting H23 as negative 0.01666666667. We'll just round it to give us that. Last equation is 2H13 plus 6 H23 plus 9 H33 is equal to 0. That's our top row of our matrix. 2H13, if we bring the other term to the other side, it's negative 9 times 0.0556 minus 6 times negative 0.0167. If we do that math, let's double check. I'm just doing it on my calculator. You get roughly, again, negative 0.2. So if we come back up now, we can substitute our final H values here, which end up being negative 0.2 again, negative 0.0167, and 0.0556. I'll just rewrite it here. So now we have our final answer. And again, this is our inverse of A, which is 0.2, 0.10, negative 0.2, negative 0.2667, 0.2222, negative 0.2, negative 0.0167, and 0.0556. And that is our answer for the inverse. So just to recap what we did, it was a lot of work, but we took A and decomposed it into its lower and upper triangular matrices by doing a Gaussian elimination, and we kept track of our multipliers along the way. I confirmed in MATLAB we could have done the matrix multiplication on paper if we wanted, that if we multiplied L and U together, we would ultimately get back the original A matrix. And then to find the inverse, we note that if we multiply A by its inverse, that will give us the identity matrix. And then if we do LU decomposition, we see UH as being a new matrix Z. And then we use this matrix multiplication idea where if we multiply any row from A by a certain column in Z, that'll give us that same column in I. So the rows of L rather, the rows of L multiplied by column 1 of Z gives us column 1 of I. The rows of L multiplied by column 2 of Z gives us column 2 of I. And the rows of L multiplied by column 3 of Z gives us column 3 of I. And that's what we did every time to find our unknown Z values. And then ultimately, once we knew those Z values, we went ahead and said that UH is equal to Z and repeated the exact same process. So we did this, setting things equal to columns thing ultimately 6 times. 3 to find Z, and then the final 3 to find the inverse. So I hope that this was helpful. If you have questions, obviously, please come let me know. Thanks, guys.